When we did the first half of 6.3 notes, we talked about annuities. This is the second half of 6.3 notes where we're going to talk about the sinking fund. The sinking fund is when a person or an entity with a debt may decide to accumulate sufficient funds to pay off the debt by agreeing to set aside enough money each month or quarter or year so that when the debt becomes payable, the money set aside each month plus the interest earned will equal the debt. The fund created by such a plan is called a sinking fund. In working with sinking funds, we generally seek to know the deposit or the payment required each month or each year or semi-annually to reach the certain goal. In other words, we seek the payment P required to obtain the amount A. Well, in our case, we use different letters in ours, and we're trying to find out the D required to obtain P sub N. Okay, so we use different letters for our formulas. It's the same formula, however, compared to your book. It's just different letters. Now, this sinking fund is really a lot like annuity because you're saving up that money to pay off the debt. So it's like a savings plan in essence, and you're paying each periodically. So month, year, or whatever you're paying. And then once you get to that value that you need, then you get rid of those funds by paying off that debt. So we'll be using this formula right here, the first formula, the one that was always on the left, to compute these problems. And so our first problem is example 7, because again, this is a continuation of 6.3. So the Board of Education received permission to issue a $4 million in bonds to build a new high school. The board is required to make payments every 6 months into a sinking fund, paying 4% compounded semi-annually. At the end of the 12 years, the bond obligation will be retired. What should each payment be? So they're going to, build this high school. They're going to save up this money because they've already built the high school. They've accumulated this debt, and they're going to save up the money in this bond, in this sinking fund, to then pay it off altogether. So we're going to start with the $4 million on the left. That is the P sub N. And yes, I am writing out the $4 million here. All right. And on the right-hand side, what we don't know is how much they got to pay twice a year. And then we have the 1 plus, the rate is 0.04. The number of times it's compounded is semi-annually, so that's twice a year. The exponent is then the number of years being 12 times semi-annually, so NK. Then we have to subtract that 1. And then we're going to put that all over the 0.04 divided by 2 once again. Now, because the missing number is on the right-hand side, we're going to go on to Desmos and figure out what that D is by seeing where the lines intersect. Okay, you can see on here where I entered all of my information into both the y equals to figure out where they intersect on the graph. And then I had to change my window. I changed my y max value to 4,100,000. And then for the x max, I just started typing 5 and a bunch of zeros until I could see where they intersected. And so the intersection is 131,484 and 39 cents. So remember, that's paid biannually or twice a year. So let's go back to the equation and write down what the answer is. So we have D equals $131,484.39. So that's how much the school board will pay twice a year so that they can save up and pay off this bond. Next, we have example 8. A town needs $1 million for capital improvements. The town administration decides to finance improvements with a 30-year bond that will pay 5% per annum interest twice a year. A sinking fund is set up 5 years in advance of the due date for the bonds to be paid off. The administration projects that the sinking fund to have a monthly payments and to earn 4% interest compounded monthly. What are the semi-annual payments on the bond? So we have two things happening here, which makes it a little bit more complicated. The first thing is asking about the bond. Now the bond is paying 5% per annum interest twice a year. And so if we want to know the annual interest on that, we want to say $1 million times the 5%. That's 5% for the entire year. That's going to give us $50,000. Okay. And this is going to be the total for the year. So when we want to find out how much is paid in the semi-annual payments, we would just take the $50,000 divided by 2 because of the semi-annual. And so we have $25,000 semi-annual payments. So that's part A. Now the sinking fund uses our annuity payments. So we have the $1 million equals D, and then we have 1 plus the 4%, because remember it's 4%, and it's monthly. We have monthly for 5 years. And then we're going to divide by the 0.04 over 12 again. And so again, because the D is on the right-hand side, we're going to have to go to Desmos to find out what D equals. Now I was able to use this same window, the same setup as my other problem. And so you could see on the left-hand side picture, we have the $1 million and our formula. My D moved down a little bit, but don't worry about that. Whether the D is in the numerator or on the side, like I have it in this picture, it won't affect it. You just don't want the D in the denominator. That really does affect the whole outcome of this. And so we have these payments of $15,083.19. So let's go back and write that down. We have $15,000, 83, and then 19 cents for that. So that's the monthly payment required for the sinking fund part, whereas the bond itself is also getting payments. All right. In the next part, we are going to set up a table so you can see what's happening during each year of this sinking fund and deposits and the interest. Okay, so we have this table for part C. I apologize for my table not looking as good as yours. That's because whenever I transfer this over to my iPad, the lines fall away. So I don't know what to do there. We already know that our sinking fund deposit is $15,083.19. So I'm going to fill that out for all of these. That's how much our deposit is. Now the cumulative deposit in 1 year is still that $15,083.19. There's no interest accumulated just yet. So then our total is $15,083.19. Now to find the cumulative deposit column, you're just going to multiply these two columns together in order to get the cumulative deposit. All right, so I've filled those out. Go ahead and pause the video here so you can copy those down. The next column I'm going to fill out actually is the last column, the total column. Now, before we go over how to do that, keep in mind that payment number 12 is 1 year. Payment number 24 is 2 years, 36, 3 years, 48, 4 years, and 60 is 5 years. We're going to need that for our annuity formula, our sinking fund formula. So just to go over what your formula is going to look like, we have our deposit each month of $15,083.19, with the percentage being 4%, and our monthly payments, and so on. So what you're going to do for the first column, or for the first line there, is we're going to find out what happens after 1 year. And so we put that into the calculator. And you can see that Desmos has given me 184, 353, and 73 cents. So I'll go and fill that back out on the table. The next thing we want to do is we just want to switch this number here to a 2, then a 3, then a 4, then a 5, so that we can calculate all the other pieces of that table. You can see here that I've just changed that number to a 2, and so we have $376,218.32, and so that's going to go under payment number 24, representing the 2 years. Okay, so coming back to the table, I have those payment number 1, payment number 12, and payment number 2 set up. You can pause the video here while you try to calculate the other 3 values using 3, 4, and 5 in that same formula on Desmos, and then unpause so you can get and copy down the rest of the numbers and verify your results. Okay, hopefully your numbers match up to mine. Now, please notice that the last number, which I've written out a little bit more than I typically write cents, has an extra 0.084 cents. All right, so what they want us to do, because we never want to overpay or over deposit, that's not how this works. And typically you'll notice if you ever take out a loan that your last payment will be a little bit less than you've been paying all along. Not by much, but just a little bit. So they want us to round this up to 9 cents. Now I know that's kind of awkward because we don't often do that, but I believe that it was 0.08473. So they're suggesting that this is approximately 9 cents. All right, so let me change that to 9 cents. Now we don't want to overpay by 9 cents. So what we'll be doing is taking 9 cents off our 60th payment. So let's go back to the very first the second column, the sinking fund deposit, and change that 19 cents at the end to 10 cents. So I'm going to be removing those 9 cents from there. Now that changes our cents right here as well in the cumulative deposits. Okay, and that's going to be 31 cents. And that will, in the end, remove any existing change. And so that we have $1 million exactly in our total for our last column. Now, in order to get the accumulated interest column, we take the total column and we subtract the cumulative deposits. So starting on the bottom, if we took the million minus the 904,991.31, we're going to get 95,008 point with a change of 69 cents there. So make sure you go and fill out that accumulated interest by subtracting the total minus the cumulative deposits. So pause the video here and then come back to see if your numbers match up to mine. All right, there are the numbers. Hopefully they match up to mine. Now this sort of table is the kind of thing you would give to a client so that they can see how many deposits are made, what the cumulative deposits are, and more importantly to them a lot of the times, what the accumulated interest is. How much interest are they being charged, or how much interest are they paying, that sort of thing. So they want to know that. A lot of clients do as they're paying loans. So hopefully this kind of table helps them. They don't always, skip years like this. Sometimes they show every single payment. So it's a pretty long list when you go out to 60. Okay, that is the end of our notes for 6.3b. I will make a different set of notes for 6.5.